Assalamualaikum and hi. Alright, from the previous video, okay, we already discussed about how to solve real problems through mathematical modeling, which involve the function of linear and quadratic. So this is the last part for the mathematical modeling. So in this part, I'm going to discuss about how to solve real problems through mathematical modeling, which involve the exponential functions. It's about a compound interest, which is interest that is calculated based on the original principal and also the accumulated interest from the previous periods of savings. Okay, ini bermaksud faedah compound di mana faedah yang kita dapat okay, daripada simpanan yang kita buat, dan faedah tu juga dikira daripada jumlah jumlah simpanan yang kita buat tu. So here at the beginning of a year, Mr. Gomez saved 20,000 in his savings account with an interest rate of 4% per annum. Per annum maksudnya per tahunan lah, 4%. And the interest is compound once a year. Faedah ni diberi sekali setahun. So now derive a mathematical model for Mr. Gomez total savings after 3 years of saving. Solve this problem through mathematical modeling. For mathematical modeling, okay, to solve problem using mathematical modeling, you must do the 6 components. Okay, so the first one is identifying and defining the problem. So our problem here is compound interest once a year, and then the principal is 20,000. Yearly interest rate is 4%, and what we need to do, we need to derive a mathematical model for total savings at the end of T years. Okay, T yang kita tak tahu boleh jadi apa-apa saja. Okay, so from here, the second step is we need to make assumptions and identifying the variables. Okay, of course, if you want to use this data, this table afterwards, okay, this is what you need to assume. Okay, we must assume that Mr. Gomez did not withdraw or raise his saving. Sepanjang waktu simpanan itu, dia tidak mengeluarkan ataupun tidak menambah simpanan dia. Kalau tak, nanti dia dah larilah daripada formula tu. Okay, so here this is the variables involved. Principal amount, that is P. Yearly interest rate, we call it as R. Number of times interest is compound, and bermaksud berapa kali faedah tu diberi. Okay, berapa kali faedah diberi. Okay, then time, we assume that is as a T years. The third one, we need to applying the mathematics to solve problem. So here we have every year we have 100% of the principal, of course, and then plus with the 4% of the previous balance. Okay, so we'll do the first year first. Okay, here okay, I'll show with the highlighter. Okay, here the principal is 20,000. The interest received, of course, how are you going to get the interest received? 20,000 times with 0.04. How come you get that 0.04? Because it gave you 4%. So 4 over 100. Okay, then how you're going to get the total principal plus the interest? Of course, you need to plus the principal and the interest received. Okay, here this is 20,000 the principal. Okay, see, this is the principal, this is the interest received. Okay, so from here, okay, you can do the factorization. you can do the factorization, which bring out the same number, okay, which bring out the same number with same factor. Here we have 20,000, so you bring out the 20,000, then inside you will get 1 plus 0.04. Okay, it might be someone that asked me, why this one must be 1? Because 20,000 times 1, you will get back 20,000. Okay, and this one 20,000 times with 0.04, nampak? Okay, when you multiply it, masuk dalam balik, dia akan jadi balik atas. See? Okay, from this, the green one, you will get the amount of savings at the end of year 1. This is the amount of saving of year 1. 20,000 multiplied with 1.04. Mana datang 1.04? Here, 1 plus 0.04. Okay, next. For the second year, of course, takkanlah nak remain principal as 20,000. It must dah berkembang, dah bertambah. Okay, it will be 20,000 multiplied by with 1.04 here. See? So this principal, how to get the interest received? Of course, this principal, okay, you must multiply with 0.04 because every year we have that 4%. Okay, time with the 0.04. So, what do we call it? From this data, then you will get this. The principal plus the interest will be, so this is the principal, okay, and this is the interest. Okay, interest. But here. Okay, as usual, when when you see like this plus, okay, addition here, when you see it can be factorized, you will factorize it out. Okay, seems that here we have that 20,000 and 1.04. Okay, both we have this 20,000 and 1.04. So you bring it out. Okay, after you bring it out, okay, it will left 1 plus with 0.04. Okay, 1, 2 comes from the first one, and this is the second one, that 0.04. See? Here, just want to see the pattern. Okay, this one, 1 plus 0.04 actually will be equals to 1.04. This one also will be 1.04. Okay, so this 1.04 we have twice, will multiply with 20,000. So here, amount of savings for this at the end of second year is 20,000 multiplied with 1.04 square. Okay, ada dua kan, 1.04, so will be 1.04 power of 2 square or square. Let's see the pattern for the third one. Okay, here this is the total amount savings at the end of year of the second year. So itulah yang bawa ke tahun ketiga ni. So this is the principal. Okay, so how much that you will receive for the interest? Of course, the principal multiply with 0.04. This is the principal time with the 0.04. Okay, so principal plus the interest you will get. Here is the principal. Okay, plus with the interest. The interest is here. Okay, as you can see, okay, what you can see here, okay, it is the same. between the addition, we have that 20,000 and 1.04 square for both. So we will factorize it out, okay, and then we'll get this. Okay, so do the same step. Okay, why we have this power of 3? Because here we have 1.04 square. Here also we have another 1.04. So we have 3 1.04. That is 1.04 power of 3. Okay, so this pattern will same goes to 4th year, 5th year, and 6th year, and continue until T years maybe. Okay, so that is what we want to know. That is the mathematical model that we want to know. We want to find out, so that will be easier for us to calculate for any years that we want. Okay, here it's just the same step. Okay, you will see a pattern here. Okay, you will see a pattern here. Okay, so from this applying mathematics, so the fourth one, you need to verify and interpreting solutions in the context of the problem. So here, at the end of every year, the amount of savings is the power of 1.04 times the principal, 20,000, and the power corresponds to the number of years of saving. Okay, as you can see here, it is to the power of the year saving. Year 1, power of 1. Year 2, power of 2. Year 3, power of 3, and so on. Okay, so that is the meaning of the sentence. Alright, then we can generalize it to a mathematical model. Okay, when we see the pattern, as the previous example, we can see that, oh, it looks like quadratic function, so that's why we're going to use the quadratic function, the general quadratic function, to create the mathematical model for that situation. So for this, okay, from the pattern that we get, this is what we will get. The total amount of savings for T years actually equals to the P, okay, P principal in a bracket 1 plus R power of T years. Okay, so as you know, note that 1.04 actually you get it from 1 plus 0.04, and the 0.04 is actually the value of R. Okay, the value of R, the the interest rate. Okay, so here, okay, you might plot a graph, okay, from the data you got. Okay, you might plot this type of data. Yes, you will got this type of data, and this one will shows an exponential function. Okay, it will shows that exponential function, that is the total savings for T years actually equals to 20,000 multiplied with 1.04 power of T years. Yang ni saya dah tunjukkan tadi. Okay, so now how to refining the mathematical model. Okay, here this formula, okay, it might be used for annual compounding. What happened? Okay, but actually the interest often compound more frequently. It might be semi-annually, mungkin setengah tahun, or quarterly, setiap 3 bulan, or monthly, bulanan. Okay, so if monthly, the interest rates you need to change to R over 12. Why? Because R is per annum, setahun. So kalau every month dapat this interest, you have to divide it by 12. Okay, but then the variable T, okay, the variable T here, okay, is multiplied by 12. Okay, why? Because this is the years. Okay, setiap tahun dapat. But then setiap dalam satu tahun tu dia dapat 12 kali. So that's why you have to multiply it with 12. Okay, perasan tadi ada satu variable that is n. N is the number of interest being compound. Okay, so here this mathematical model might be like this. The total savings, okay, the total savings for T years, it might be P in a bracket 1 plus R over 12 and power of 12 T. Okay, this one if it is a monthly. Okay, if it is a monthly. Sebab tu dia divide 12, yang ni pun darab 12. Sebab dalam setahun tu dapat 12 kali. 12 kali lah kena darab dengan tahun tu. Okay, so here the general form that you will get, okay, it will be, okay, the total savings for T years, it can be P in a bracket 1 plus R over 12 power of nt. N stand for the numbers of how many times the interest being compound. Okay, darabkan dengan T yang tahun tadi tu. And the sixth step is reporting the findings. You just need to have a full report following the above modeling framework structure, just like what I suggest in the second example. Okay, you can just make a summary of it. Just explain anything that from the findings that you have in the 1 to 5th stats. Okay, so I think that's all from me. Hopefully my videos can help you in understanding more about mathematical modeling. See you again. Bye bye. Assalamualaikum.